Hi there, my name is Christopher Tepetitlan, a Senior Application Engineer with Shining 3D. Today we're going to take a look at the full digital workflow for fabricating a digital night guard using intraoral scanning and 3D printing. For intraoral scanning, we'll be working with Shining 3D's Aoralscan 3 wireless and the AoStation, which is an all-in-one computer with touchscreen. For the design of the night guard, we will be using the CAD modules that are included with the Shining 3D software. And for 3D printing, we'll be using the AccuFab-CEL, FabWash, and FabCure N2 from Shining 3D. Let's get started with the intraoral scanning portion. Intraoral scanners function by using structured light technology to acquire data. A DLP projector will project a pattern onto the object that's being scanned, and a camera within the scanner will be collecting the data to see the distortions in that pattern. This will allow for accurate measurement data to be gathered, while also collecting the color texture data at the same time. Each frame of scanning, the light will be turning on and the camera will be capturing image, and this will be repeated multiple times per second. And these images will be stitched together by cross-referencing the previous frame of the scan. This method of collecting data is what allows us to get fast speeds and accurate data, and will also dictate the workflow we'll use when collecting the data. So let's jump right into our scan by going into our AoStation and opening up the intraoral scan software. On the home page, we'll start by creating a new order, and we'll enter in the patient information on the left side of the screen. For new patients, we'll also need to add additional information, such as age, and we'll like to select our dentistry type. We'll set to orthodontics for creating a night guard. Depending on the dentistry type you select, there will be different modules available at the end. So here we'll begin our scan. At each step of scanning, there will be an animation in the top left corner showing you what you should be doing at each step. You will also receive some helpful tips and tricks during the preheating of the scan tip. This is going to be our main scan interface, and we'll see what step we're on in the top center of the screen, highlighted in blue. So first we're going to be scanning the upper jaw. Now before we get started, let's take a look at some of the settings and modes that we have available in the software. So firstly, in the bottom left corner of the screen, we have our intraoral mode and our edentulous mode, both of which will optimize the scanning software for the environment within the mouth with or without teeth. For scanning a dental model like this, I'll be using without intraoral mode. On the right side of the screen, we also have some additional options such as our intelligent scan or AI mode, which will be important for helping clean up the data as you're scanning. This is going to filter out extraneous data such as tongue and cheek and glove, making it easier to clean up your data as you're going, reducing the amount of data you'll need to clean up as you're scanning. There's also the metallic tooth button. This is going to optimize the scanner for picking up data on highly reflective surfaces, such as a metal tooth or filling, or a partial, for instance. This can help if there's a lot of saliva in the mouth as well. I will demonstrate how the scanner operates with and without AI on. So if I turn off AI and start the scan, you'll see that it's going to pick up my finger while I'm scanning. This will be extra data that will need to be removed at the end of the scan or between steps. Otherwise, it will take up space or could even get in the way of the data itself. Let me reset the scan and turn AI on. Now when I start our scan, the scanner is going to filter out finger data, and even if it picks it up, it will eventually delete it. You may have noticed that when I pick up the scanner, it immediately enters scan mode. You can change this in the settings menu if you wish to press the button to start the scan, but you can also use the button to pause the scan while you're scanning. As for our scan strategy, we're going to start in the posterior teeth, or in the molars, and we're going to get an entire occlusal sweep with the scanner. Then we're going to go for a sweep of the lingual and the buccal. It's important to get the entire occlusal surface first, as this will be a reference point when it's stitching together the data. This will make going back and collecting more additional data easier. So now I'll pick up the scanner, it enters scan mode, and I'll get in position above the molars. Now I'm going to do a quick sweep of the occlusal surface from one side of the arch to the other, before moving down to the lingual and around to the buccal. For the incisal edge, I recommend coming from the top and rolling over the incisal edge. This will help the scanner keep track a little better in those areas. If I pause the scan, we can rotate the data and see any holes in the data highlighted in green. To fill these in, I'm just going to pick up our scanner, go into those positions, and since we have reference data around it, the scanner is going to pick up where we start. It's very easy to get our first 3 passes and then go in and fill in any holes. And I can just rotate the scanner slightly, get better angles. To progress with the scan, we can either hit the check mark, or we can use the scanner's gyroscope functions by double-clicking the scan button to bring up our radial menu. I can wave the scanner upwards to rotate the data to look for those holes, or I can hold to the right to move to the next step. This will allow you for a hands-free scanning experience, so you don't have to contaminate the computer while you have your gloves on and such. So it's helpful from getting through the entire scan before having to use the mouse or the touchscreen. So next we'll scan the opposing. And we'll move on to our bite scan. Once we have our patient in occlusion, we're going to scan the patient's left side first. And we're going to get the scanner into position near the back of the mouth. And we're going to move up and down and move towards the anterior teeth. Once we see the 2 sets of data from the right side of the screen fly into the center, we know we've picked up enough scan data. That is pretty fast, so we'll do that again on the patient's right side. So we'll start at the posteriors and just move up and down and move slowly towards the anteriors until the 2 sets of data, the upper and the lower, fly into the center of the screen. Once that's done, you can pause the scan and we can see that we've collected enough data. If you want to add a 3rd scan, you can hit this plus button here and scan the anteriors. Once we have the upper, lower, and bite scan, then we can proceed to our pre-design stage. The pre-design stage is going to be where we have our collection of CAD modules, including our night guard design, crease splint. We also have a model builder, an indirect bonding tray design, and a single unit temporary crown design module. So here on the pre-design, we'll go to more applications and select crease splint. For this application, I would suggest using a mouse, as that'll make it easier to do the design. So in our new project page, we're going to select our type between splint and retainer. So for this, we'll select splint, and we're going to select the arch that we want to create the guard for. I'm going to select the upper jaw. Next, we can change the margin style to meet our preferences. Personally, I like to go with the half coverage and then modify the margin line later. But we have other options as well. Next, you can change some thickness settings, and if you want to see a visual representation of the setting, you can hover over the eye icon. So I think we'll be good with these settings. If you make any changes to these settings, they will be saved for the next time you use the software. We'll start by using the auto generation, as this will be the simplest workflow, and then we can go back and make changes to our guard after the software has designed it initially. So here we have our proposal guard. And if we're happy with the automatic design, we can go ahead and print this, but I would like to make a few changes first. So we'll go back to the case parameters section, number 2, and we can adjust the margin line. So we have the option to draw or set it to control points, so we can modify each point along the margin individually. I'm going to hide the lower jaw, and using the pencil tool, we can adjust our margin by simply clicking and dragging. Once adjusted, it will regenerate the margin, and we can rotate to find different angles. If we want the lingual side to be a little higher up, we can always draw in our new margin line. And you can even draw while it's regenerating. Nice. We can readjust the parameters that we set at the beginning on this menu as well. I'll select Next Step, and we can now modify the surface of the guard itself. We have an option for a sectional view, so you can get a bisected view of the opposing and the guard to see how much space we have in between. We can use our virtual articulator to adjust the bite. And once adjusted, we can use our static bite adjustment or dynamic bite adjustment to carve out the opposing teeth from the guard. So if I do this and remove our lower jaw, we can now see that the opposing teeth have been carved out from the guard itself. Now these edges may be a little sharp, so we can use our carving tools at the bottom to smooth out that surface. So I'm going to set my brush strength and size, and we can paint over the rough edges to smooth them out a bit. You can also use these tools to add more material or remove material from the guard. The experience is fully customizable. Once we're done making changes, we can select Next Step. Here we can add text to our guard as well. And we'll select a surface to add the text to. This can make it easier to identify which case the guard belongs to if you're printing multiple at the same time. So from here, we can export this night guard for printing on other printers as an STL file, or we can send it straight to our AccuFab-CEL printer using the Go to Print menu at the bottom right corner. First, I'm going to select the Print Settings menu, and I'm going to ensure that our settings look correct. We have our printer selected, our material selected, and our layer thickness, and our one-click printing type. I'm going to hit Save, and then Go to Print. If you have AccuWare installed on your computer, it will automatically open AccuWare, load the necessary print settings, and commit to our one-click print for the night guard workflow. One-click print is going to go ahead and orient and add supports to your night guards, optimize it for the printing experience. Here we're given a results page that will show us our projected material consumption and printing time. We have the option to save, send, or print the model from here. Save option will allow us to place the file on a USB drive and insert it into the printer manually. Send will send the file over the Wi-Fi network to our printer and add it to the printing queue. The print option will automatically start the print if the printer is in standby and ready to go. We will still need to prepare our printer ahead of time, so we're going to go ahead and hit send to add it to the printer queue. After sending the file over the Wi-Fi network, we must now prepare the printer for the print. First, we'd like to ensure that the resin profile selected on the printer itself matches that of the profile we selected in AccuWare. So for this demonstration, it will be SS01, our soft splint resin. Next, we want to pour some additional resin into the resin tank to fill up to the minimum line. Be sure to shake the bottle of resin well before pouring out. Once the resin is at the minimum line, we want to use our rubber spatula to mix the resin very well. At the same time, we can use the rubber spatula to comb the bottom of the resin tank to feel for any debris at the bottom of the tank. We want the tank to be clear of any debris, as debris in the tank can cause damage to the film on the bottom of the resin tank if pressed into it during the printing phase. Make sure to mix the resin well before every print. Once our resin is mixed, we'll go ahead and close the hood of the printer and open our printing queue. Here we can see the file that we sent over the Wi-Fi network. And if we select that, we can start our print. Now while our print is happening, we can discuss a little bit about how resin 3D printing works. Resin 3D printers use a method called ultraviolet masked photopolymerization. Each layer of printing has the build platform lowered down to the layer height position. The light source of the printer will turn on, is masked through the LCD screen of the printer, which projects a 2D image onto the bottom of the resin tank. This image will cure the liquid resin, solidifying it and adhering it to the build platform. The build platform will then move upwards, peeling from the bottom of the resin tank and moving back down into position for the next layer. The printer will slowly build layer by layer the 3D model using these 2D layers that we call until the 3D model is complete. We are printing upside down, so we are working against gravity. This means that we need to make sure that parts like night guards have enough supports to hold them up during printing. 3D printing can get pretty messy, so be sure to wear nitrile gloves when handling liquid resins or isopropyl alcohol, as both can be irritants to the skin. The best way to clean up spilled resin is to use isopropyl alcohol and a soft paper towel. Once our print is complete, we can remove the build platform from the printer and we'll be moving to our post-processing unit, starting with the FabWash. The FabWash is an automatic cut, wash, and dry machine, so we just need to place our platform in the platform holder and set our settings to cut and wash and change our material profile to match the resin we're using. Once we start this process, the FabWash will then lower the platform into position. The sensor that's on the platform will let the wash know where is level, and a blade will come out and cut the parts from the platform. They will fall into a basket, which will then lower into a tank of isopropyl alcohol, and a magnetic impeller will agitate the alcohol, cleaning the parts. Once this process is complete, The platform holder and basket will raise out of the tank and be left to air dry. We want to make sure that our parts are completely dry before we put them in our post-process curing machine. For night guards, since this is a pretty sticky resin, we may want to run an additional wash for half the recommended washing time to help clean up the parts. Both our FabWash and our FabCure units will have preset profiles for each of our resins, and you can program custom profiles to match your needs. After the parts have been washed, we'll need to remove the supports from the night guards. These should come off fairly easily by just peeling them off, or you can use wire cutters to cut them off. We will let these air dry on a paper towel for a little bit longer before putting in the curing unit. Next, we will place the night guards into our FabCure N2, which is a post-process curing machine that uses nitrogen gas. The nitrogen gas will fill the chamber, replacing any oxygen, which will prevent any chemical reactions between the oxygen, UV light, and the surface of the model which has not been completely cured yet. This allows us to maintain color accuracy of our applications and improve the surface texture quality of our part. Once the curing is complete, we could remove our application, and we would proceed with any post-processing grinding down of supports or polishing of the parts. At the end, we are left with our 3D printed night guard, which fits nicely on our model. This completes our walkthrough of the complete digital solution from scan to print of fabricating a digital night guard. Thank you so much for your time.